Hi viewers, welcome to today's lecture on center of gravity and centroid of shapes. The center of gravity of a body is defined as a point in a space through which the resultant pull of the earth acts for all possible position of the body. It is defined as a point through which the lines of action or the weight of the body always passes, irrespective of the position of the body. We can also define it, or the center of gravity, as a point at which the center weight of the body appears to be concentrated. So let's illustrate this with a point here. Let's look at a triangle. We have a rectangle, we have a triangle, we have a circle. So for the rectangle, if this is this point here, we refer the first point here as A. If this is A, let me pick a better color, and we have call this B. I will call this C, and this is our point D. So, and here we have this as our point A, here we have our point B, and this is point C. Here we have, if we pick a line, or we draw a line from point A, this point here, to point D, and we pick another line from point B to point C. So where these lines, and we pick another one from here, let's say from here to this plus, so we are having where this, the point of intersection of these several lines we've drawn is called the CG of the shape. So we'll call this that is where the center of gravity of this shape is expected to lie. So this point here is, at this point, this is where we call the center of gravity of this point here, is the center of gravity of this shape. So for the second shape, which is the triangle, if we pick a point from A to the extreme end here, let me repeat that again. So if we pick a point from A to this point, and we'll pick another point from here to this point, from C to this point, and from B to this point. So the point of intersection of these three lines from A down here, from B down here, and from C here, which is here, we'll call this as the CG. This is where the CG of this body is expected to appear or to be. Then for the last one, which is the cycle, if we pick from any point for the cycle, we can pick any point from here to here. It doesn't have vertices, doesn't have any vertices, so it only has circumference. So from this point to this point, and from this point to this point, from wherever point we decide to go, from here to here. So we expect that the center of gravity is expected to be at the center from here. So this point is known as the CG of this cycle. So this is where we call, this is the CG of this. So this is center of gravity, the CG of this shape. So we've seen the point of intersection of the lines passing through the rectangle, passing through the triangle, and passing through the cycle. So for a typical rectangle, which we have here, this is a typical rectangle. We want to, this rectangle, this one, so we want to determine its own, where this, since the center of gravity is expected to be at the point where the lines intersect. So if CG, if this is the line, let's say this is the rectangle, and here we have the extreme end of this rectangle, then we'll have this. So, and the sides of the rectangle, here let's say the total length of this, the longer side of this rectangle is represented by L, is L, and is equal to L. So it means our CG is supposed to be at the center, so which is here at this point. So it means from here to here is supposed to be L over 2, and this, from this point to this extreme, is L over 2. So the CG of this rectangular shape from the along the x-axis is L over 2, from irrespective of the point you're coming from. Are you coming from A, B, C, or D? So from C to D along the x-axis, it is L over 2, because if the total length is L divided by 2, which is half of L over 2, is this is center of gravity. CG for this shape will be equal to L over 2. So if we are coming from this side, if the distance between here to this point, if the distance is, let's say, is y or is k, so the center of gravity along that axis, the y-axis, will be, CG will be equal to k over 2. So viewers, this is where we'll come to the end of today's demonstration on center of gravity and centroid of shapes. So this is the starting of the first lecture. In the second lecture, we'll be talking about, or we'll be illustrating this with more examples. We will look at the center of gravity of two bodies on a straight line. So we'll illustrate that. So I expect to see you in the next video. For now, I remain Engineer Obuna, and please, if you have not subscribed to our channel, do so by clicking on the subscribe button. You can also press the notification icon in order to stay notified on our new videos. See you in the next video. Bye for now.